Our third topic for today is going to be factoring quadratic expressions. And specifically, we're going to be looking at quadratic expressions where a is equal to 1. So I'm starting with my standard form of a quadratic, ax squared plus bx plus c. And basically, I'm wanting to convert it to my intercept form of the quadratic, which is two sets of parentheses with binomials in them. Intercept form is also called factored form, and just like factoring out a greatest common factor is undistributing, factoring a quadratic from standard form to our factored or intercept form is kind of a double undistributing. So let's talk about multiplying first to get a quadratic, and then we'll see how factoring is doing the opposite. So you may remember from Algebra 1 an acronym of FOIL, which stands for first, where we multiply the first terms of each binomial together. And then we do the outer pieces, so that would be an x and a -2 in this case. The inner, so 3 times x. And then finally the last terms of each binomial, my 3 and my -2. You may have seen arrows drawn to visually depict this distribution that we're doing. All right, so if we do this distribution, we have an x squared, and then we have minus 2x plus 3x and minus 6. We have a couple of like terms that we can add together to give me -2 plus 3 is going to be a positive 1, so x squared plus a positive 1x, and then minus 6. All right, so notice that now I have a quadratic expression in standard form. An ax squared plus a bx plus a c, my a is equal to 1. So let's take a look at the pattern that we followed in order to get each of these terms. So if we look at this x squared term, we got that x squared by multiplying the first numbers of each of those binomials together. So it was this x and this other x multiplied together to get x squared. So if I want to replicate that part of the pattern and go backwards, let's say on problem number 9, I know that the front of each of my parentheses needs to be an x because those multiplied together will give me an x squared. The middle term is an x, a 1x, and I got that from two different places. I got it from this -2 and this positive 3x. So that's from my outer terms being multiplied together and my inner terms being multiplied together, and then added. The other thing I want to notice is that I have a -6 at the back end, and that's from multiplying my last terms together, my positive 3 and -2. So thinking about that pattern, I'm looking for two numbers that are going to add together to give me the middle number, but multiply together to give me the last number. So it's kind of a two-step process, or two things to think about. So let's take a look at that with our example here. I have a last term of 15, so I want things that are going to multiply to be 15, but add to be 8. It might help you to create what I call a T-chart, since the chart looks a little like a T. Put your factor or your last number, your C, at the top, and think of factors that will multiply together to be that. A 1 and a 15 is a possibility. 2 won't divide into 15 evenly, but 3 will. 3 times 5. 4 will not go evenly, but 5 will, and 5 times 3. Oh, I already have 3 times 5. I don't need 5 times 3. So now what I want to look for is which of these two sets of terms will add to be a positive 8, and it's 3 plus 5. So I can write my factored form with a 3 here and a plus 5 here. We can check this by going the other direction. I have an x times an x gives me x squared. I have 3 times x, that's a 3x, x times 5, that's a 5x, so 3x and 5x is going to give me 8x, and then 3 times 5 is 15. So it does go perfectly backwards, and so I can say that that is my final factored form of my quadratic. All right, let's take a look at example number 10. I'm going to go ahead and create my parentheses, and I know that an x goes in the front. After that, I can create a t-chart, and let's say 56, and I need factors of 56 that are going to add to be a negative 18. All right, so I need to multiply to be 56, but add to be negative 18. Well, the only way that that can happen is if both of my factors are negative, because two negatives will multiply to be a positive, but they will add to be a negative. So as I create my t-chart, I want to use a negative 1 and a negative 56. Negative 2 will divide into 56 negative 28 times. 3 will not divide evenly. How do I know that just at first glance? Remember that your rule for dividing by 3 is if you add the two terms or the two digits together, so 5 plus 6 is 11, that's not divisible by 3, so the overall 56 is not divisible by 3. Negative 4 will divide, and I'll have a negative 14. 5 doesn't go evenly into 56 because I'd need a 5 or a 0 on the end for that. 6 doesn't work because in order for 6 to work, 2 and 3 both would work, and I already threw out 3. The next one's going to be 7, and negative 7 and negative 8 will also make 56, positive 56. All right, let's take a look and see which of these will add together to be negative 18, and I'm going to look at negative 4 and negative 14. And so that is my final factored form. I would like you to go ahead and try number 11. It's pretty similar. Use a t-chart if you need it, but I do want you to start thinking about being able to do these in your head without a t-chart. So give it a try, but if you need to do a t-chart, that's perfectly fine for now. All right, so some of you may have recalled from your multiplication facts that 42 is 6 times 7. That's probably the most common one. And 6 plus 7 is equal to 13. If we stick negatives on both of them, that's going to equal negative 13. So our final answer, again, using the t-chart if you needed to, we know that both terms had to be negative to get a positive number when multiplied and a negative number when added. Let's go ahead and look at number 12. This time I have a negative 24 as the thing that we need to multiply to be. So if I have a negative 24, that must mean I have one of each. I have a positive factor and a negative factor. And because I have a positive number here, I know that my bigger number, my bigger factor has to be the positive one so that it overtakes that negative number. So I'm going to start with a negative 1 and a positive 24. Well, that equals 23 when I add it. Definitely not 5. Negative 2 and 12. I'm getting closer because negative 2 and 12 add to be a positive 10. Still not at 5. Negative 3 and 8 will multiply together to be negative 24. And negative 3 plus 8 is actually the one I'm looking for because that adds to be 5. You can stop there, but if you're not doing this math in your head as you go along, you may just go ahead and continue your factoring until you get all the factors and we start repeating. Negative 4 and 6, that's gone too far because we get a positive 2. 5 won't divide into 24, and then we're back to a 6 and a 4, which we already have taken into account. But you can stop right there at the negative 3 and 8 if you recognize that that's the factors, if you are even using a t-chart. So I'm going to say negative 3 and a positive 8. All right, one more. I'd like for you to pause the video and then come back and see if you were able to get number 13 correct. All right, problem number 13. we have numbers that need to multiply together to be a negative 54, but add together to be a negative 3. So I know I have one of each, a positive and a negative, and because they add to be negative, my bigger factor needs to be the negative one. So that's the way I've set this up. I've listed all of my factors with the bigger one being negative, and the last set, 6 and negative 9, are going to add to be negative 3. So that gives me a final factored form of x plus 6 and x minus 9. Now you may be asking yourself, does it matter which order these go in? And the answer is no. X plus 6 and x minus 9 is the same as x minus 9 times x plus 6. So it does not matter which order you put these in.